So what exactly is a VPC? Well, it stands for Virtual Private Cloud. You can think of it as virtual networking. In essence, it is virtual networking. It's just different name that AWS gives it as it gives all of its other technologies. Now, if we were to slap a definition around it, it would be a logically isolated network in the AWS cloud. Now, I'm going to show you diagrams to better illustrate this in a little bit here. Now, it also gives you control of network architecture. Now, what that means is you're going to get control over your topology, over your subnet architecture, over your IP address routing, over your gateways. It's also going to give you enhanced security in the form of egress security groups. So typically, you would get ingress security group access, right? With the use of a VPC or with VPC's extensive enhanced security, now not only are you able to put security groups on inbound traffic, but you're also able to put security groups on outbound traffic. You're also able to put routing rules. You're also able to put things like access control lists in place. So all of the traditional networking security that you're used to in your on-premises data center, you're able to port these practices. You're able to have familiar access to things that you've done on premises in order for you to do the same thing in an Amazon virtual private cloud. You have the ability to do internetworking with other organizations. This is really cool. VPC peering, we're going to talk about it a little bit later also with diagrams to better illustrate it. But if you have a VPC in the AWS cloud, you're able to also interconnect that VPC to someone else's VPC, whether you're a partner that you're trying to help them, you're a consultant, maybe it's a different line of business that you're trying to connect to. Whatever the case is, you can interconnect your VPCs. You have the ability to get elastic IP addresses. Now, when you spin up an instance on AWS, you're going to automatically get an elastic IP address, which essentially means a public IP address. But you have the ability here of adding additional IP addresses to your VPC. The first elastic IP address that comes with the instance is free, and then the second one comes at a cost. Now, you can also enable your hybrid cloud. And what does that mean? So you have the ability of extending your on-premises data center to connect to your VPC in the AWS cloud. And we're going to talk about the different gateway and VPN technologies that are available. It's essentially a site-to-site VPN, but you have the ability of doing direct connect and some other technologies as well to have better bandwidth, better throughput, lower latency, better performance, etc. The VPC costs you nothing. It's free. And as of this recording, VPN costs were about 5 cents an hour. So again, anytime I talk about costing or pricing, keep in mind I'm doing this as of this recording. So you always want to double check that because a lot of the pricing with AWS and most of the cloud providers for that matter is constantly changing. So I would highly recommend that you're always double checking these prices. Well, let's talk a little bit about what it looks like from a VPC perspective. So the VPC, let's assume this was the internet, right? Now, on the internet, AWS has to be able to kind of logically isolate its infrastructure from the rest of the world, right? From the rest of the internet. So even AWS, think of even the AWS global infrastructure as a large VPC. It's essentially a logically separated instance within the internet. Now, because AWS is going to have multiple tenants that live within their global infrastructure, they need to provide these tenants with a way to isolate themselves from each other, essentially. That was where the concept of a VPC came about. So within the AWS global infrastructure, AWS makes available the virtual private cloud, virtual networking, which allows you to isolate, to put up this logical instance out there within that global infrastructure where you can put your resources within it and then logically secure yourself from your other tenants. Now, you're probably wondering, okay, well, this is from a networking perspective, but what do I do for the rest of the Amazon services that are out there? Let's take a look at what an AWS kind of a reference architecture looks like, and that'll make the picture a little clearer. So from a reference model perspective, you have the AWS global infrastructure, we just talked about in a second. On top of that immediately is your networking. So on top of networking, now you can have your compute, your storage, your database. Again, networking is able to put that wrapper around all of these services to make them isolated and make them essentially just accessible by you and whoever else you give access to. Now, on top of that, you get application services and you get deployment and automation. This is a typical AWS reference model. Now, if we take networking here, it branches out into VPC, and as you can see within your VPC, now you can have logical control over the compute, over the storage, over the databases, over the other services that Amazon also offers. So within that VPC, you're able to put all of these controls in order to logically isolate yourself from the rest of the tenants that live on the AWS global infrastructure. VPC Access. We talked about the fact that you can connect to the VPC from your on-premises. There are several different ways of doing this. You have gateways and you have VPNs, right? So from an internet gateway perspective, or otherwise known as IGW, essentially what this is it's a device, it's a virtual device that will allow ingress and egress traffic to the internet, right? Inbound and outbound traffic to the internet. You have what's known as a virtual private gateway, VPG. That is the AWS side of a secure VPN. So if you needed a device to connect to on the AWS side, it would be a virtual private gateway. Now, a customer gateway or a CG is the customer side of a secure VPN. So on premises, you would have whatever device that you have there. That device would connect to a VPG. So those are the gateway options that you get with VPC. From a VPN perspective, you have two options. We're going to start off with Direct Connect. Direct Connect, you use that whenever the VPN connection is no longer enough. So with a Direct Connect, it's a dedicated and isolated communication link into your VPC, right? So there's no internet there. You have high availability connectivity is supported and recommended, obviously. So you have essentially, it's like an MPLS. Think of it as MPLS. So it's another node on your MPLS network, or it's a direct connection into your VPC. So it gives you that extension of your on-premises with high availability. It gives it to you with dedicated bandwidth and throughput, and you're able to put quality of service on there because you know what you're expecting out of this link. It's no longer reliant on the internet. Now, for the most part, you also have access through a traditional VPN, and that traditional VPN could be hardware-based, right? So if it's hardware-based, it's on premises, you can use that again to connect over the internet to your VPC. HA connectivity is supported. Third-party brands are also supported. So if you're using Cisco or Juniper or whatever VPN hardware appliance that you have on premises, make sure that it's supported for access to VPC. But the point here is there's broad support for this type of connectivity. So again, you have your traditional internet access to the AWS cloud. Depending on the types of workloads, the types of applications that you're going to put on Amazon, latency might be a problem. Maybe if you're putting a tier 1 application out there, you're not going to be able to establish that using a VPN because what you're going to get dinged on is latency. It might need 5 millisecond or less latency, and at that point, that's when you start considering Direct Connect. Direct Connect again gives you those faster links, lower latency, predictable performance and availability. Now, it's also important to note that the VPC is region-wide. So you can, your VPC is going to be accessible region-wide, right? Now, that being said, it could be accessible across multiple availability zones within that region. Now, subnets, on the other hand, are availability zone specific. However, the thing to note here is that all subnets can route to each other by default. So if you have two availability zones with multiple subnets in it, they will route to one another by default, and it's up to you, again, to restrict them. That goes back to that shared responsibility model here. They are giving you all of these resources. It is now up to you to secure your network the same way that you would secure your network on premises. It's the time to scrutinize the network now, figure out what is set up by default. When you're putting up a router, there's a lot of things that are set up by default that you might want to switch off or turn off. The same thing applies here. You're going to have to figure out what's Amazon is giving you, what comes with that VPC by default, and you take it back a notch, you turn off whatever you don't want to be accessible. It's also important to note that your resources are going to get internal IP addresses. They're not always necessarily going to get a public IP address. Some resources will, like an instance, other resources won't. So it's up to you to provision elastic IP addresses or public IP addresses for those resources that need to be internet facing if they don't come with an elastic IP address. Now, I also mentioned security groups and access control lists when we were talking about VPC enhanced network security. So with a security group, what you're getting essentially is resource level traffic firewall. This is very important because this is kind of the differentiator between the different security models that the VPC offers you. So with security groups, you're getting resource level traffic firewall, which means you're able to place those controls at the instance level or essentially at the object level, right? So whether it's an instance or it's an ELB or whatever that object may be, you're putting it at that object resource level. That's where the firewall rules are being set. Now you can set ingress and egress traffic, so inbound and outbound, and it's stateful, which means the return traffic is always going to be allowed. Those are some of the highlights of a security group. On the other hand, with access control lists, and for those of you that are network savvy or that are network engineers and administrators know this very well, the difference between security groups and access control lists, but I definitely want to give you kind of a high level overview here just so you have an idea of what you're in for. So with access control lists, you're able to do source and protocol filtering. You're able to do subnet level traffic firewall. So again, subnet level traffic firewall versus resource or object level traffic firewall, where you're able to separate inbound and outbound rule sets. You're able to do stateless, which means you're able to scrutinize the traffic and you're able to strictly filter it. So return traffic is not always going to be allowed. You might be able to, again, set different types of rules against it. So it gives you a lot more flexibility. Once you get into access control lists, again, this type of security model has been around for a very, very long time, and all of network engineers, anybody that's dealt with the network is probably an expert at how to configure these. So this won't be different than what you've done on premises. You just have to apply the same best practices. All right, we talked about VPC peering, and this is a really cool concept. So let's say you have a VPC, and again, VPC peering will only be allowed region-wide. But let's say you're a consultant. You're a consulting company and you have a VPC on Amazon. And you happen to have other clients on Amazon. Well, what you can do is you can establish these links. You can extend your network to connect to your other companies. So let's assume VPC2 and VPC3 were two companies of yours. Well, you can connect into their subnets, right? You can connect into their network. Now, this is not necessarily a gotcha, but what you need to make sure happens here is that your IP address scheme has to be different than their IP address scheme. They cannot overlap. So that's one thing you have to take into mind. And that might change in the future. So again, as of this recording, these are some of the limitations, but make sure you double check to see if that's still available. Now, I've given you the example here of a consulting company. Now, you're probably wondering, well, Eli, what if I'm VPC3? I'm this company number 3 here, and you're my consulting company and you're VPC1. Does that mean that I can now jump through you and get access to VPC2? And the answer to that question is no. So that's where no transitive peering is allowed. So you cannot use me as kind of a jump board to get access to somebody else's network. That will not be allowed. Amazon specifically restricts that. But the VPC peering is very helpful because, again, if you're a consulting company and you're connecting to your client's network, now you have also access to the full power of that network behind it, right? All the network links that are connected to it, the MPLS, everything. You have access to that backbone. That's one thing. This can also apply for different lines of businesses. If you have different lines of businesses within your organizations, acquisitions, this would be so easy for an acquisition if both companies are using AWS. If you have partners that you're trying to connect to, whether it's for applications, for APIs, for integration, this is just a phenomenal little gem that AWS has out there. So again, you can't use it to jump from one company to another. That's not allowed, but you have the ability of connecting your VPC to multiple other VPCs. Again, within the same region is the gotcha. So inter-VPC routing, that's available. You have to have, you can use the same or different AWS accounts to do that. And there's no overlapping network addresses will be allowed at this point. Elastic load balancing is probably one of my favorite topics at AWS. I love ELB. It has so many features. It's got so many good use cases. Let's get right into it. Let's talk about what it offers. So it's region-wide load balancer. So keep that in mind. It can be used internally or externally, which means you can use it to load balance or use all of its other features, whether you're accepting traffic from the outside or whether you're trying to load balance internal resources. It has SSL termination and processing, and that's really cool. And I'll get into that again once I start showing you diagrams. Well, but what SSL termination and processing essentially means is if behind that load balancer you have several instances, let's just take web servers. If you have 2 or 3 web servers behind that load balancer, Without SSL termination, that would mean that you are going to be required to have an SSL certificate on each of these web servers. With an SSL termination, now you're putting the SSL certificate at the load balancer level, and as a result, the rest of the servers behind the load balancer no longer need an SSL certificate. Now, if I was to simplify this and give you kind of a visual for how a load balancer works, a load balancer might essentially create a virtual server at the load balancer level, and you're installing that certificate at that virtual server level in the load balancer, right? So that would be you're getting a certificate for that virtual server name. Now the load balancer spreads the traffic, so the security is happening through that load balancer, which is why you don't need multiple SSL certificates. Now, as far as processing is concerned, the SSL processing is also happening at the load balancer, which means it's removing a performance hit that you could possibly take if you were processing SSL at the server level, which means if you have a certificate at each one of those web servers and you're routing the traffic to it, now it has to process that SSL. It has to make sure it's doing that encryption, decryption for SSL. Instead, by offloading the processing to the load balancer, all of that processing capabilities is now happening at the load balancer. As a result, your web servers are going to perform better. It's really an awesome feature. ELB EC2 health checks. This is also really cool. So at the load balancer level, you're able to establish, or you're able to perform health checks against those servers, in my example, against those web servers that are behind that load balancer. So if a particular server is experiencing heavy load, if it's offline for whatever reason, then the load balancer can take it out of the pool of where it's load balancing traffic, and it's not sending traffic to it anymore. And I'll show you this again in a diagram in a second. Route 53 will also perform ELB health checks, and this is extremely cool because this avoids a single point of failure at the ELB level, at the load balancer level. So you're able to have multiple load balancer instances, let's call them, or appliances, and Route 53, which is AWS's DNS, will be able to make sure it's performing health checks against these load balancers. And if it detects that a load balancer isn't performing or is offline, then it kind of takes it out of the DNS route table, so that the users that are requesting access, they are not being routed to that load balancer anymore. They are being routed to the load balancer that's online, which is why DNS is so crucial, not just at AWS, in general. In any kind of a data center build out, DNS is the most crucial component, because if DNS is out, forget about it. You can have all the high availability, all the redundancy that you want. It only takes DNS to go down for the rest of the stuff to be kind of pointless. Let's take a look at some diagrams that will further clarify everything that we've been talking about. So if I'm a user, and again, I'm trying to establish a connection to a web server, right? So the user is going through Route 53. That's the AWS DNS. The DNS is pointing them to that elastic load balancer. The load balancer is then spreading the load to the web servers, let's say, in that availability zone. So keep in mind here, I have them in one availability zone, and I have my load balancer in one region. Now, if a health check is performed and one of the servers is deemed to be problematic, whether it's offline, whether it's consuming a lot of load, whatever the case is, and it's not meeting the particular threshold that you've configured at the load balancer level, then what you simply do is you're removing that particular instance out of the pool. And at that point, the load balancer is spreading the load, that's the incoming load that's coming in, against the two servers that remain in my availability zone that are meeting that criteria. Now, I'm giving you an example of 3 servers here. It could be 200 servers, but the point is the health check is going to go through that determination, and if a particular instance isn't meeting the criteria set, then it takes it out of the pool. It's really, really cool. All right, let's take another example. What if I'm a user that's connecting through DNS? And again, keep in mind that while it is region-based, you can have ELB kind of spread or load balance across multiple availability zones. So again, the same thing applies here. You know, that load is coming in. Maybe you want to load balance across 2 different data centers because you have, I don't know, maybe faster servers, or you're trying to transition. And this could be an awesome way for you to transition from one data center to another if you're trying to do that. Or in this particular example, you can also use this in the form of an active passive data center. So in this case, maybe you make one of the links, the availability zone 2, for example, inactive, right? So let's just assume for a second that was an inactive link. In the event of a disaster, right, and availability zone 1 is out, that's your data center, your primary data center. If that's out, all you would have to do is then configure that elastic load balancer to essentially disconnect that link from availability zone 1, and voila. As far as your users are concerned, now they're being routed to availability zone number 2. So it's really cool that you're able to do that, again, at the region level. Now you can use global server load balancers and spread the load balancing across multiple regions. There's a lot of different ways of architecting these types of things, but the elastic load balancer that AWS provides is region-based. If you're using a NetScaler, which has the capability to do global server load balancer, and you're installing that as an appliance on AWS, then you could do across region, for example, load balancing and some of this other advanced stuff. Now, let's assume, we talked about this, that you're worried about the load balancer being a single point of failure, and that's a very legitimate concern. Because again, if that load balancer goes down, well, essentially you've lost access. I mean, users have lost access. So that's where Route 53, Amazon's AWS's DNS, is able to perform health checks against the ELBs. So if it detects that a particular ELB, let's say, is offline or is not meeting certain criteria, whatever the case is, if it's offline, let's say, what it does then is it's going to remove it, and it's going to fail over that DNS in the routing table to the load balancer that's actually functioning, and the load balancer that's actually functioning will then take over the load or the processing of that load to your instances. It's really a beautiful thing. Well, what do you guys say we take a look at the VPC and see what are the configurations that are available to us, and how do you create one? Let's go ahead and jump into our management console real quick. So when you're coming to this familiar screen again, you're going to scroll down, and under networking, you're going to find VPC. So once you've launched VPC, you're going to see that you already have an instance, but you're going to be like, well, I didn't really create one. Well, the first VPC is going to be automatically created for you. So if you go ahead and click on that VPC, you'll be able to give it a name if you wanted to, like with all the other services. So for example, this could be my, I don't know, production VPC. So I can give it a name, and you'll find that again it gives you what kind of a subnet address block that it's creating. So the address here, and it's a /16, and it gives you all sorts of information around this particular VPC. And down here you get a summary of what's going on and any kind of tags that you've configured for it as well. Now, creating a VPC is very easy. So you just up here you click on create VPC, and we're not going to go through the creation process because there's really not much to see. You're just going to give it a name. That's the name tag. You're going to select your block, your subnet block. So whether it's a 192.168 or it's a you're going to do a /16 or /24, whatever the case might be, and you're going to select your tenancy, whether you're going to have it distributed, or you're going to have this dedicated, or you're going to have it default essentially. So for the most part, everybody uses the default tenancy for this. You're not going to have a dedicated a VPC for something particular, like a line of business or anything like that. So once you've filled out this information and you've created it, there's really nothing beyond this. It just pretty much adds an entry that's very similar to this. But in the background, what it will do is it will go through and create your subnets, for instance. So based on the subnet scheme that you've created, it's going to come in here and it's going to create your subnets for you, or you're going to create some subnets based on that. And you can come in once you start to configure your subnets and you're adding your route tables and your network access control list. This is where you would come in to add those network access control lists, and your route tables are in here. So once you've done these, and depending on what you've done, then you can begin to name these subnets. So maybe one of them will be private, the other one will be public. Again, based on the rules that you're giving them, you'll be able to give them a friendly name so that you can pull from these subnets when you need to, when you're provisioning other resources. On the left here, you can click on route tables. So again, I'm taking you through this, but as a network administrator or someone who's dealt with networking in the past, this should be very, very familiar for you. Nothing is really different here. You can go ahead and click on create route, and you're essentially adding the name tag, and you're specifying the VPC against which you want to do that, and you can go through the process, and it will allow you to start building these route tables that you need to do. Internet gateways, it has one again that's selected, and Down here, you have an option of taking a look at, what are the configurations for it. You can add tags for it. You can create an additional internet gateway if you choose to do so. So again, things that you should be familiar with. Your DHCP configuration happens in here. So if you need to use DHCP, you can do it in here. Elastic IPs, these are any public facing IP addresses that you want to provision. Again, you can do them from here as well. Your peering connections, we talked about the idea of having your VPC connect to other VPCs. This is where you can come in and configure that also. So you click on peering here, and you're filling out all the necessary information. Now, down under security, you have your network access control lists that you can configure. Again, very typical type of stuff, nothing groundbreaking or different than what you're used to. Security groups, again, remember security groups are object-based or instance-based or resource-based, so you're able to come in here and again start building those. Your VPN connections, whether you're trying to specify your customer gateway or you're specifying your virtual private gateway, or any type of VPN connections that you want to establish, whether they're with hardware or direct connect, again, you can do all of that from your VPC. So you see how the VPC kind of consolidates your virtual networking for your entire environment and allows you to kind of isolate yourself from the rest of the tenants within AWS. There are so many cool services that AWS offers. And honestly, every time I start talking about one, I kind of start to like it more than the other, but Route 53 has got to be up there. Route 53 it's a kick-ass DNS service. There's really no other way of putting it. So let's take a look at why I'm saying this. So DNS is crucial for any environment, right? We talked about this a little earlier. If your DNS goes down, no matter what redundancy you've built, no matter what you've done in the data center, it doesn't matter. Nobody's going to be able to get access to you. Nobody's going to be able to find you. Nobody's going to know how to route to you. So DNS is crucial. DNS has to be up. And depending on the line of business that you're in, if you're in e-commerce, then DNS becomes all the more important. And depending on the type of business that you're in, if you're an organization that is an e-commerce organization, for example, that's spread worldwide, and you need to have access, you need to give someone that's connecting from Australia has to be able to connect to find the DNS server that's closest to them so that it can resolve that IP instead of sitting there trying to connect. Now, that's why it's important when you're signing up for a DNS service or when you're thinking about hosting your own DNS service to say, well, how many DNS servers can I bring up? 1, 2, 3, 4? Well, what is the latency going to be to, or what's the response time going to be to those DNS servers? If I'm putting those servers, and for example, I'm in Chicago, if I'm going to put those 4 servers in Chicago and I have customers in Australia, am I expecting those customers to travel, all, throughout the continents essentially to get access to these DNS servers? That's going to be, it's not going to be responsive enough. Your customers' experience isn't going to be ideal. Well, one of the things that you can use Amazon Web Services for is DNS, and this is a service that you can use outside of all the other services. You don't have to use any other Amazon Web Services service for that matter. You can just use DNS. And the reason I say this is, from a Route 53 perspective, it is worldwide distributed DNS. Amazon has more DNS presence worldwide than probably any other providers. Recall in earlier modules when we were talking about the edge locations? Well, Route 53 is one of those services that is available at every one of those edge locations worldwide that AWS has. Now you're probably wondering, well, how many edge locations does it have? Let me refresh your memory. These are all the edge locations that AWS has. There is a DNS presence in every one of those edge locations. See up here? It says CloudFront, and we're going to talk about CloudFront later, but AWS Route 53 is available in every one of those edge locations. So again, think about it. If you're an e-commerce business, wouldn't you want to host your DNS with an Amazon, for example? I sound like a commercial here, but it's the truth, right? I mean, look at this. There's a DNS server everywhere. The likelihood of a user in any part of the world not finding a DNS server that will give, that will respond in a timely manner, I don't know. You tell me. So this is why, sometimes offloading some of these services to a cloud service provider will extend the capabilities of something that we couldn't do even if we wanted to. Even if our on-premises data center is awesome, we couldn't do this. I mean, it's next to impossible. It would be cost prohibitive for us to do this. So even if you're not leveraging the cloud for everything, you should understand that the cloud has some features and capabilities that we will never be able to reach, which is why leveraging AWS for certain things like Route 53, well, in my opinion, you should leverage it for a lot more, but in particular for something like DNS, is almost a no-brainer. All right, back to our presentation. So are you impressed yet with Route 53? Nah, not yet? Okay. Well, what if I told you Route 53 has a 100% SLA uptime? Amazon is saying Route 53 cannot go down. It will not go down. It has an SLA of 100% uptime. Beat that if you can. Now that is pretty cool. Let's talk more. So Route 53 also has an API, right? So if you are a developer, if you are an organization where your primary application required some kind of an interface or automation to DNS, well, as with most of all of the AWS services, they have APIs. Route 53 also has an API. So theoretically, if GoDaddy was an organization, for example, that decided, you know what, we are going to leverage the Amazon DNS servers for our applications. Well, then theoretically, GoDaddy can interface with the Route 53 API so that every time you register a domain or every time you want to create some kind of a record in your DNS entry, that that GoDaddy is able to automatically add those entries within the route tables for DNS. And that's just a simplistic use case. Obviously, depending on what you're doing and the type of application, it could be a lot more extensive. But again, there is an API out there which you can use. Now, another cool thing, server health checks. Now, let's say you are not hosting your servers, your instances, your VMs, whatever you want to call them, on AWS, but you want to use AWS's Route 53 DNS service. Well, the DNS service itself allows you to do server health checks. So let's say your servers are on premises and they're public facing and you have servers 1, 2, 3. Well, you can configure your Route 53 so that it is constantly pinging these servers. And in the event that it finds that a server is not responding, it no longer resolves to that particular server. And speaking of that, it also has the ability of doing some lightweight load balancing, where it can load balance the traffic between some instances. So it has the capability of doing that as well. Some form of round robin. A little, you have a little more handle as far as that, but essentially server round robin from a DNS perspective. So you have the ability to do a lot of cool things with Route 53. This is definitely one of the flagship services that Amazon offers. Now, if you're anything like me, you probably don't like monitoring systems. As a matter of fact, when I was in corporate America, I used to despise them just because of the number of alerts I used to get, and they were honestly useless. I mean, it's up, down, and the only time I would look at it is when something was broken or when something was red and it needed my attention. But as you start to get into cloud, monitoring becomes crucial. It becomes crucial because, again, this is not an environment that you've built. This is something that will alert you when something goes wrong, and a lot of things can go wrong, but it can also be used for billing. So CloudWatch is essentially your monitoring system that AWS provides in the cloud. Now, you get basic monitoring, which is an offering that you get for free. And that allows you to monitor up to 7 metrics, right? So you want CPU, memory, IO, instance, ELB, whatever it is, up to 7 metrics that you can monitor for free. And you get to query these metrics every 5 minutes. So you have a 5-minute interval when you can query them. Now, this is the basic monitoring, again, that you get out of the box with AWS for free. You have a little more advanced monitoring or detailed monitoring, whatever you want to call it. You get over 10 alarms, 1 million API requests. So again, if you have, and like I said before, almost every AWS service has an API, including CloudWatch. It has an API that you can integrate with. So if you have a third-party application where you're integrating with CloudWatch, or if you have your own built application that you're connecting via API, you're able to get up to 1 million API requests, and you have an interval, response time, and you can query those every 1 minute. So again, that gives you an idea of what you get with the advanced type of monitoring. You have the ability of setting alarms and alerts and also taking action against them. Now, I'm not going to spend too much time on this because you're probably experts at this, whether you're using, Ops Manager from Microsoft, or I don't know, what's up Gold, or there's a slew of them out there. VMware has, everybody's got a monitoring system, and depending on what you're using it for, it's either the best thing that's ever happened, or you hate it and you dread it. Now, setting alarms, alerts, and taking action against them, it's something you've done, right? So you might set an alert or an alarm if a particular server CPU goes over 80% and stays there for 50 minutes. And that might be, in your opinion, something that's abnormal, which will trigger a notification that goes out to you, and it'll also at the same time maybe reboot that server. Maybe that is what you've set as the next step for fixing or addressing this issue, would be to reboot that server. So that's one aspect of it that you're familiar with. The aspect of it that you're probably not familiar with, and which is why I like CloudWatch and it becomes crucial for cloud, is billing. One of the things that you have to learn about the cloud, if you haven't figured this out so far, is if you don't have the discipline of knowing what you're paying for, you're going to end up spending a lot of money. And to be honest with you, as you start your journey into cloud, as you start your journey into AWS, you're probably going to be spending a little more than what you honestly really need, but that's until you establish that threshold. However, if you're given a budget of $1,000 to spend and you end up spending $5,000, that could become a problem. So in order for you to stay within the limits of what you're able to spend, even if you're spending more on certain things, maybe you're spending more on a particular instance's uptime or whatever service you're consuming, maybe you need to spend $200 and you're spending $300, but it's still within that $1,000 budget. But what you should do is set alerts and alarms around your billing, so that, for example, if you're $1,000 budget for the month, and we're a week into the month and you're already at $800, well, without an alert or an alarm or a notification that goes out, you're definitely going to be over that $1,000 budget, and you're going to come at the end of the month and find, okay, I got a $5,000 problem that I have to deal with. But if you set alarms, which means I want you to alert me via email, text message, whatever it is, when I've spent $250, then you're going to get a trigger that's going to go out to you and say, hey, you've just exceeded $250 in spend. And then another trigger maybe at $500, and another trigger at $750, and maybe a huge big trigger at $1,000. Well, that gives you the ability of figuring out how much you've spent so far, what day of the month is this, how much more money do you have, if you need to tweak anything to make sure you're lowering your bill. So it gives you that flexibility. So CloudWatch is huge when it comes to getting your billing under control. Definitely use it, especially if you have budgets that you have to adhere to, so that you're keeping everything in check. So use it for all the monitoring capabilities, but again, I'm not going to spend time because you're used to it. Specifically, use it for your billing capabilities. It gives you notification via either simple email services from Amazon or simple notification services like text messages, SNS, also through Amazon. You have the ability of doing custom monitoring through APIs. So again, if you've built up a particular application and you want to configure it to tie into the CloudWatch API, you have the ability to do that. Again, all Amazon services are going to have an API of sort that you can tie into. It integrates with auto scaling. Now, we haven't talked about auto scaling yet, but we are going to. But before I do that, the last thing that I want to leave you with before we move off of this slide is that there's also a mobile application for basic monitoring and management. So you can download this on your iPhone or your Android device or your Windows device, whatever it is. You can download this particular mobile app and you're able to do some monitoring and management of CloudWatch. Now, this is useful because, again, if you're not waiting for those emails to come in or those notifications to come in, and if maybe a mobile application is something that you are more comfortable with, something that you like to check every so often, then you can do that for basic monitoring and management. And again, if you're configuring billing, you can go into your mobile app and see, hey, how much have I spent so far? So it's very useful. But let's go back to auto scaling. We talked about the fact that it integrates with auto scaling. Before we talk about, well, how does it integrate with auto scaling? Let's define what auto scaling is. Auto scaling is one of the coolest features, in my opinion, that AWS offers. For starters, what it gives you is the ability to expand or shrink your EC2 instances on demand. Now, if you think about it, that is at the heart of the cloud proposition, right? The cloud proposition is all about that elasticity, that ability to add more workers, more servers when you need them, and to shrink those when you don't need them, and the ability to automate that process so that if your servers are running at 80% CPU, well, hey, guess what? That's the time to provision new EC2 instances in order to offload some of the work that's happening on some of the other servers onto newer servers in order to provide a better user experience. Hence why we said autoscaling integrates with CloudWatch. Because if CloudWatch is that monitoring system that you have for your AWS services, and if CloudWatch is going to be the one that determines, well, the servers are now running at 80%, CloudWatch is now going to trigger autoscaling to then provision newer EC2 instances in order to bring that threshold within the acceptable guidelines that you have specified, or within the acceptable thresholds that you expect your services to be running at. That is that integration portion that we talked about with CloudWatch. Autoscaling allows you to expand and shrink. So that's really, really cool because it's doing that also automatically, and you don't require a lot of programming or a lot of development skills to do that. That is the beauty of why I love this particular feature so much. Now, you can do this again using CloudWatch. I mean, we talked about that extensively. Or you can also put this on a manual schedule. So if you wanted, for example, if you know that at the end of every month, you're going to require an additional EC2 instances, well, then you can configure autoscaling on a particular schedule. Hey, I want you to, at the 25th of every month, to provision 5 new EC2 instances. And then I want you at the 30th of every month to deprovision these 5 particular instances. So you have flexibility in either integrating it with CloudWatch or building some manual schedules that you can configure in order to accomplish this particular task. Now, you have the ability of also being notified. So if your autoscaling is provisioning newer EC2 instances, you're going to get notifications again, a number of different ways that you can get notified. So notifications are a big thing. And finally, the best of all, autoscaling is free. Now, when I say autoscaling is free, the service itself is free. You don't have to pay to use autoscaling. But keep in mind, nothing is really free with Amazon, right? So while they're giving you the service for free, it's technically an incredibly smart thing to do. Well, what does this service do? This service in particular provisions other services. So they want you to provision other services because those other services are going to consume compute, they're going to consume storage, they're going to consume database services, they're going to consume ELBs, they're going to consume a whole slew of peripheral services or additional services that Amazon offers, which is why they'll give it to you for free. Why not give it to you for free? This is the perfect service that allows you to provision additional services. But I get it, you need a visual to kind of see how autoscaling works. So I put together this awesome animation that I want to share with you on how autoscaling really works. So you have your users that communicate with Route 53 DNS, and DNS is going to point them to the load balancer, right? Now the load balancer is going to point them to the least busy servers from the servers, the instances that are available, the web servers that we have in this particular example. So that's traditionally how it works, right? Nothing crazy here. Now these web servers happen to be in an auto-scaling group, essentially, right? So you'll see that on the right I have availability. So availability that is not currently being used. Now what happens is, based on health check, for instance, it can also, obviously, if you have health check here and one of those servers isn't functioning properly, we've talked about this earlier, it can take it out of the pool. So all of that is part of it as well. But health check is also going to help you determine if there's a load on these particular servers. So if you're integrating it with CloudWatch, for instance, and it's detecting a particular load, if these servers are starting to all be utilized at 80% memory or 80% CPU, or maybe the storage isn't performing up to your standards, there's a lot of load on these particular servers for whatever the reason is, what autoscaling will do is it will then provision 3 new instances, 3 more web servers automatically. It will drop them into that pool, that autoscaling pool, which is also configured behind that elastic load balancer. So now your users are being spread across 6 instances as opposed to 3 instances, and that load should technically go away, right? Now, conversely, once that load goes away, maybe the load balancer, maybe those thresholds go back down. Maybe you are no longer performing at that high of a threshold. What the auto scaling can do is it will then shrink back once those levels come back within acceptable uses, right? Now, I took back all 3 of them. Maybe auto scaling will determine that, well, I need 4 in order to maintain the thresholds, the performance that you've required out of this particular system. So it'll leave 4 as opposed to, it'll remove 2 as opposed to removing 3. But you get the idea. You have the ability of shrinking up or shrinking down and growing, or, expanding your environment more than what it is in an automated fashion, which is why auto scaling is so cool. This was probably my favorite module to record. It goes to the heart of the AWS proposition. It goes to the heart of the cloud proposition. It also highlights the importance of the certification track. Just imagine, as a consultant, as a cloud architect, what you can do and how you're going to be able to help your customers or your organization migrate to the cloud or build services on top of the cloud. Very, very crucial. So let's go ahead and summarize what we learned real quick. We started off by talking about virtual private cloud, VPC. What is a VPC? We talked about the fact that it is a way of logically containing, logically securing your resources on the AWS cloud so that they're isolated from other tenants on the global infrastructure that AWS has. So you're able to put all of your services and, figure out or dictate who can or cannot get access to them. So you get extensive security in the form of security groups and access control lists and so on and so forth. We talked about elastic load balancing, right? We talked about the fact that with an ELB, you have the ability of doing server health checks. So you're able to check against the servers that are in that pool that you're load balancing against and figure out if there's a server that's offline or a server that's not performing adequately. You can take it out of that pool and load balance across the others. The elastic load balancing is a fantastic and very powerful tool as well. We talked about Route 53. Do I need to say anything else about Route 53? It is an amazing global distributed DNS that has a 100% uptime with locations across the world. So your response time from a DNS perspective is just phenomenal. We then moved on to CloudWatch. CloudWatch is that technology that allows you to monitor your instances, not just your instances, all of your AWS services. You're able to monitor them through CloudWatch, but in particular, we focused on how you can monitor your spend, your billing, and getting alerts as far as, well, how much you've spent and making sure you have control over that. CloudWatch is also very, very cool. Finally, we talked about auto scaling, probably, again, my favorite AWS feature, and that's the feature that, again, goes to the heart of the cloud proposition, that elasticity that we've been talking about, the ability to grow and shrink the environment on demand, automatically, automagically, without necessarily having to write a lot of code, a lot of scripts to do that. So with AWS, if you have a pool of servers and these pools of servers are, for example, reaching a particular threshold where they're not able to cope anymore with the load, well, with auto scaling, you can provision additional resources to help get that load off. And then, conversely, when that load is gone, you're able to shrink that environment in order to, again, first of all, save money, because you don't want these instances to be running if there's no particular load that justifies them. And second, you don't want to spend that money, right? So auto scaling allows you that flexibility of growing the environment and shrinking it. Finally, I hope this module was very informative for you, and I'd like to thank you for viewing.